So, welcome again. Today we're gonna talk about wood, but before we're doing that, I have to show one of the last prototypes, because this one looks very fine. It's a 4-module version here. You can see like this, and they are cut from 1 centimeter acrylic glass. And they look totally gorgeous, but they have a big problem. Let me explain on the single module here. As you can see, this module is quite simple, and it has a quite simple problem, because I was very stupid when designing it. Not sure if you can see it like this. Yeah, this should work. See that crack here? This stress fracture, like I think would be the correct term. It comes from tightening down those bolts onto the plexiglass. And I wish this would be the single case I had from this, but no. They all have it. Not every module had it from beginning. In the beginning they all looked good. But after some thermocycles, heating them up, cooling them down, they all got stress fractures. So at this moment only this one leaks, but it's to be expected that other stress fractures will also grow, and then the other modules will also leak. So I have to revision this design. My problem at this point was I did run out of 1 centimeter acrylic plate. All I had left was 5 millimeters, and the problem with 5 millimeters is, you can see it on this, if I try to make these grooves into 5 millimeter, there isn't much left where I can cut the threads in, so the fittings are tight. So this was not an option. And yeah, what was then an option? And this brings me to wood. Lots of stupid wood. Yeah, get in there. So yeah. A few weeks back I had the idea of trying to make a watertight module from wood with this. This was the first prototype. You just place an O-ring in there. Let me just quickly get an O-ring. Here, there should be one laying around here. Here. So you just get an O-ring, place it in here, put your LED module on top, screw it tight, and then from the other side you can get the fittings in. In theory, simple thing. In practice, absolute bullshit, because naturally the wood isn't completely watertight and it started soaking up moisture. Problem then was the wood started expanding with the moisture, and it created cracks, and it started leaking as hell. So this design was out. Also, this design was something I made way earlier, not with intention to be ever tight. But next design was this. I choose to get some better quality wood, and was hoping maybe with better wood I could do it, because the last one this isn't exactly one piece of wood. Those are multiple pieces of wood just well glued together or something. And this wasn't working out, so I tried with a single piece of wood. Also, to make it maybe more tight, I oiled this wood. I put this in oil for 2 days and let it soak, but sadly it didn't work. The wood itself was tight. The problem was this side where I screw my fittings in wasn't. Basically this wood was too soft so I was not able to cut accurate threads in it, and it leaked from the threads. So this one was also out. So now at my point, I'm back in the present. I did run out of 10mm plexiglass or acrylic glass and I had to go for something else. So I decided, well, I still have a 3D printer lying around. I could just make those blocks from 3D printed material and then insert like a little piece of 5mm acrylic in it to make it tight, so I have a place where I can actually press the O-ring against. So there is a chamber, so it creates a chamber and the water doesn't actually touches the wood. In this case I was still thinking about 3D printing this, but well, then my 3D printer broke down and then all I was left was with wood and a CNC mill. So I decided, fuck it. If I can't print those, I just cut those, and I started cutting away. I started actually with this one. It's a little bit bigger since I have to take the wood that I have lying around. And this is actually the same wood which I used for the first part of this. It's a little bit too big. I mean, if you see here, it's 2 centimeters and here is it just 1 centimeters. But it worked to try it out and to see if it's watertight. And I tested it. This is the same internal design like this, with a little plexiglass piece there and an O-ring, and it's actually tight. So yeah, it isn't really a water block completely made out of wood, but it uses wood as a main part of the structural integrity. So this also fixes my problem with the cracked plexiglass, because now I screw the screws and the pressure gets taken from the screws onto the wood, and the wood distributes the pressure onto this oval plexiglass sheet in here, so I don't get stress fractures anymore. Then I tried out if I could maybe go a little bit thinner, and I had some other wood lying around, but this wood was of quite bad quality. I mean, it was 1.5 centimeters, and that's what I needed, because I have certain screws and they are only, I think, 2 centimeters or 2.5 centimeters long, so I can't go over 15 millimeters on the top side, or I won't be able to fit the screws in. And yeah, you can see this wood was very fragile, and even though this part looks fine, it actually isn't. There is a crack down in the middle, and the only thing keeping this part together is the plexiglass insert right now. So this wood didn't work out. So I went back to this idea, but like I said, I did run out of long screws and I had to improvise. And then the cracks came again. I got cracks in the side of this one, like you can see here. So I guess my solution now would be get my 3D printer running again, or get longer screws. I hope to get my printer running again. It shouldn't be such a big problem. It's just a little bit of PLA that clogged the nozzle, since I did run out of my beloved ABS and had to print those filthy PLA stuff. And yeah, it wasn't the best PLA, I assume. But that's okay. So this was the update with wooden modules. I hope you enjoyed, and maybe you did learn something, or maybe not. Just, yeah, I guess, see you next time.